or to make it stable. So how do you know whether it is borrow or not? Once you distribute the electron, this is where you do that, right? We follow all the rules, and whenever we found that central atom is not octet, we distribute all the electron, but at the central atom is not octet. In that case, then we borrow the electron from the peripheral atom. Sometime you may borrow two, generally borrow two, because they always move two, pair up. It's very hard to take one electrons. Okay? So that's how the resonance is. So when you draw the Lewis structures, follow the rules, and at the end, if the central atom doesn't have 8, then you borrow from the peripheral. So how many peripheral atoms it has? This is one central, 3 peripheral. How many canonical structure? 3. 1, 2, 3. Just like this. Let's say I'm in the center. Let's say I have 2 peripheral atoms. I can do the action of borrowing and give back twice. So I can do 2 times. Same thing in the atom. If there are 2 peripheral atoms, they have 2 canonical structures. If I have 3 friends here, I can do borrow and give in 3 times. Same thing, they can do 3 times, they will have 3 canonical structures. So know that. So resonance, how many resonance structure it has, depending upon the peripheral. 2 peripheral atoms has 2 resonance structure. 3 peripheral atom has 3 resonance structures, so and so. Okay. All right. So go over this. These are tiny mini electrons. Makes you confused. When you look at me, yeah. But when you do it, you can do it. That's how it is. Not only you, everybody. Because your brain just start thinking, but it's not enough to convince your nerve cells to move the hand the way electrons are located or moved. So you need more practice. You understand and write it first. Understand, write it first. The good thing about multiple choice question is you don't have to write it. If somehow is in those days we have to write ourselves, not a multiple choice questions. So we have to write and not need to use our hand. But it's still, you're going to be a lot easier if you write it down. Because these electrons, you never think about it that they move that way. It's very hard to convince yourself if you understand in front of me. So my point is, give more time to practice. Once you know a few things, you don't want to stop. You're fully motivated. Yeah, that's the electron life. So the point here again is these molecules, when you have proton, electron, we have so many chemicals you use other day in the lab to pour it. These chemicals, the electrons are keep moving. We don't see them. Keep moving all the time. When they do that, they also have a shape. We know that we have human beings have a shape. The chairs have a shape. These tables have shape. But same way, these chemicals also have a shape. Let's find out how their shape looks like. And that shape also is because of these electrons. And that falls under this VSEPR. Let's discuss on that one. Okay? So VSEPR is a long name, but it is one theory that ultimately helps you figure out the shape of these molecules. So VSEPR, what does that mean first? VSEPR means valence, yes, means cell, electron, here, repulsion. Very long and to make it short, VSEPR. Sometimes people say VSEPR, sometimes VSEPR. Valence, cell, electron, pair, repulsion. Okay, repulsive energy. Okay, valence cell, electron pair, repulsion theory. What does it tell you? It tells you electron globe around the central atom repels with its other. They stay as far apart as they can to reduce the repulsive force. In doing so, a unique set is built Let me repeat that. Electron group around the central atom repels each other and they stay as far apart as they can to reduce the repulsive force among themselves. Okay? In doing so, a unique set is built for the molecule. So now, let's focus on electron group around the central atom. Around the central atom. Electron group, what is electron group? Okay? So here, electron group. Electron groups are either, this is the electron group, single bond, electron group, Lewisian group, okay, or double bond, another electron group, and a triple bond, another electron group, or this is called lone pair, this is called LP, lone pair, or free pair, sometimes free pair, or non-bonding pair, or non-bonding electron, same thing. Lone pair, free pair, they are not bonded. Non-bonding pair, non-bonding electron, all. So each is called electron group. Each is called one electron group. One electron group. So for the same matter of the same, whether you have one single bond or a double bond or a triple bond or two electrons together, it's called electron group. Okay? They repel to each other. And then let's find out the Lewis structure and how the shape is formed. Let's go to, we start the Lewis structure. Let's see if there is a shape for the CO2 molecule, carbon dioxide. So CO2. Okay? So that means electron group around the central atom. So let's find out the electron group around the central atom. Again, electron group means valence electron group, because only the valence electron make this group. Okay? So, well, let's do the Lewis structure. Now you have. So how many valence electron for this guy? CO2 total valence electron is. Carbon has how many? 4. Group 4 is 4. It's very important to find that group number equals to number of valence electron. If you mess up that, you mess up to draw the Lewis structure and to have the shape of the molecule. Very important to track that. So total valence electrons group is carbon is 4 plus oxygen is 6 times 2, 16 valence electron. Okay. Now CO2, the next one after you found the valence electron, the rule says you need to find the central atom. So which is the central atom in carbon and oxygen? Carbon is towards the left. So carbon. Followed by oxygen. Okay. Now count the valence electron used up. 2 here and 2 here, 4 are used up. Remaining gonna be 5. Next one is make the peripheral octet step. So peripheral atom oxygen has 2, 1, 2, 3, 4, 5, 6, 2, 3, 4, 5, 6. Okay. So then higher, 6, 6, 12 is 1. So remaining is 0. Remaining you put in the center, but there is no remaining. Okay. So now see the stability. You have 8 here, you have 8 here, this guy has 4. So what happened? 2 of these electrons, like a double bond. So then it end up with C, double bond O, C, double bond O. Okay, so you have C. So that means you have 2 electron group. again, is around the central atom. Don't be confused here. It's around the center, not towards the, we're not counting this now. Okay, 2 electron group, because here double bond is a 1 electron group. So 1 electron group is a 1 electron group, not a group, it's a group. Okay, 2 electron group. Now, to look at it, there's 2 electron group. Like this. Carbon in the center, 2 oxygen here. Okay. So this is
Linear.
is a line. It's like a line, straight line, linear line. And we call this is linear. 1 electron group here, 1 electron group here, the bond here. 2 electron group is a linear. The angle with the central atom is 180. Right? So that means 2 electron group. We have 2 electron group. The shape of the molecule is linear with the central, and the angle is 180 degree with the central atom. Okay. Let's go to BCl3. Can you draw the Lewis for the BCl3? Draw the Lewis for BCl3. We do it this time. In your BCl3, draw the Lewis. Wow, very good. Okay. Okay. All right. So in your BCl3 total valence electrons, boron has 3 plus, boron has 7 times 3, 24. Okay. And you draw the BCl3, boron towards the left, boron in the center, chlorine, 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 and then you need a 8 now, 2 times 3 minus 6, you got 18 left, put that 6, all gone, right? And what they do, the centralized is still a 6, right? It borrows here one time, same thing like a nitrate, and then borrows from here, it goes back, borrows from here, okay, it goes back, borrows from here, back and forth. Okay? So ultimately what happens? You got a B, Cl, 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 and then you have a kind of half bond, okay, like this. Okay. Now, Let's see the BCl3, which had me, actor, right? So it's like this, boron in the center, okay? Assume I don't have a head, you'd understand that, okay? So there's no head here, boron is here. One chlorine here, one chlorine here, another chlorine mitral, okay? So what happened, if this chlorine and chlorine goes together, there's a more repulsive force. Stay as far apart as they can. Go farther, reduce that for repulsive force, farther, 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 farther. But let's see here, if you go other way here, again it is more. So that's why you cannot go down, and then it has to be somewhere here to maintain the minimum repulsive force. With that one, what happened? You have one angle here, an angle, an angle here. So they have equidistance from here, or equal angles. Okay, the angle is 120, 360. You have 3, so 120. So that is something like. Something like this. And exactly. So boron in the central, chlorine, chlorine, chlorine. Okay? Like this. So the angle is 120, 120, 120. And they are in the plane of the paper. Just like in the plane of the paper, you can see all of them in the plane of the paper. So it's a planar. It's called plane of the paper, means a planar. And they have 3 angles. Trigonal planar with the 120 degrees. So the shape is here 3 electron groups. So this is 3 electron group, trigonal, planar, with angle of 120. Okay. All right, let's do the another is CS4. Can you draw the Lewis for this? CS4. Draw the Lewis. Did you find out how many valence electron?
8.
Carbon has 4 hydrogen, each of them has 1, so it gives you 4. Which is the central atom?
Carbon.
Because hydrogen will be central. Okay, good job. So you end up with
Tetrahedron.
carbon with hydrogen. So what is the angle here?
90 degrees.
90 degrees. So this 90 degree part looks like a planet, the plane of the paper, right? So you can have all these 4 hydrogens with a carbon in the centrals, just like this. Now, but in reality what happened is, there's another way that can have least repulsive force, or they have more angles. But there's 4 atoms. There's another way that if the angle is now, this is 109, is more than 90 degrees, 109. 109, 109, yes, 109.5, okay, just like this. So they are not a planar, okay. They still like, anybody have a rough piece of paper? Any rough paper? So this is the plane of the paper, but what happened is two in the plane, that has in the plane of the paper. One is towards you, another is away from you. This is away from you. Or one is towards me, this is away from me. Okay, same thing. Two in the plane of the papers, one is towards you, another is away from you. It's a 3D structure. Okay? So this is not a planar now. Okay? And this is, in fact, we can draw this, the same molecule. There's a carbon, two in the plane of the paper, like this. Plane of the papers. One is towards you, and another is away from you. That's it. This is called weight towards you. This is dashed. This is away from you. This is the plane of the paper. So this is called tetrahedron. Now this angle is 1. So this is tetrahedron. This shape is tetrahedron. So 4 angles, but with the angle is 1. Okay. So whenever you have 4 groups around the centroatom, the point is 4 electron groups. 4 electron groups is tetrahedron. Wait, hold on. Okay. Let's see one more here. Draw this guy. Ammonia. Draw the Lewis for ammonia. Ammonia. Draw the Lewis for ammonia. Okay, how many values electron?
8.
So 5 plus 3, 8, and nitrogen is central, right? Surrounded by hydrogen. Hydrogen, so like this, right? And this is the energy here, they are somewhere here. How many electron groups are on the central atom? How many electron groups?
3. 4.
4. I just erased it. I should. Oh, I have it. See, there are 3 electron groups for this type, and 1 electron group for this type. So you have 4 electron group. So here, if you got a 4 electron group, it's a tetrahedron. Electron geometry is tetrahedron. So that means electrons stay this way, 4 electron groups. Now, there's a difference in one case. This time, what is the difference on this lone pair and bonding pair? Bonded electron. Okay? So like this one here, I have a lone pair here. This is my nitrogen here in the net. Okay? Hydrogen here, 1 hydrogen here. Okay? So what happened? What is the difference? If there is a hydrogen here, from nitrogen to hydrogen, it is tied here. 2 electrons share here. They cannot move this far. They can vibrate a little bit, but they are tied here, like a rope. Tied. But these 2 electrons here, they are a lone pair, free pair. They are not tied to anything. They can move this way or that way. So, see the difference now there. These are tight and tight here. These are free. So what happened? Look at me, okay? So this electron move this way. There's a more repulsive force. This angle down. Or down. In the 3D, same thing down. This one. So this is a tetrahedral, but the impact of lone pair is much more. So the angle reduced from regular tetrahedral. Okay? So the four electron groups. So you have, if you remember this is a 3D, you have kind of, they have interaction here. They have some kind of repulsive force with this, and same thing from the back in the 3D with this. So each of them have some kind of interactions with this guy, with this lone pair, and make a pyramid. So it's a tetrahedral, but pyramid. This is regular tetrahedral. If all these groups of electrons are identical, then it is a regular tetrahedral. But this is tetrahedral pyramidal with angle is 107, reduced because of the lone pair. Okay. So let's make a water. Find the shape of the water now. To find the shape, draw the Lewis. Draw the Lewis first. Find out how many electron groups and then decide what kind of shape it has. So H2O, total of 8 electrons, am I right? Okay, so oxygen is central, hydrogen here, okay, 2, 2, 4, remaining are 4. 2 lone pair, okay. So 2 lone pairs, sometime in the book, there is a low electron reside in the orbital, right? SPDF is the lobes, sometime you may see like this. Like this, same thing. How many electron group? How many electron group? 4. See, this is also electron pair, this is also electron pair. 2 plus 2, 4 electrons. With a 2 lone pair and 2 bonding pair. So what happens is go further down. So each of them are interacting with this guy, this guy, this guy. So that means it goes down. So that means your H is HU. This is the angle of 104.5. Even reduced. From 109 to 107 to 104.5. So this is a tetrahedral geometry, and it is a bent structure. Tetrahedral bent. So it's like
What's
this.
the angle?
Yeah, 104.5.
Why is it, okay, so logically, if there's two repulsive
Yeah, I
forces here and here, it
understand.
should make it into a
I
line,
understand.
right?
Okay, well, let me show you. So if like a CO2, if like a H2O, there's one lone pair here, one lone pair here, like another lone pair. Can I go to this? One at the top, one at the bottom. It looks like a 4 in the same plane, but it's not a 4 in the same plane. They're a 3D. Okay, so the 3D, they have interaction. So go look at it. I don't have a picture here. Go look at it. They all are interact, all of them. That's why. So I couldn't show that 3D here. Go home and find
So
out.
it's not the same scenario
No,
as the
they are
last
not.
one?
It's a 3D. It's a 3D. It's not a 2D. So like here, is the same token. Good question. Like here, this all looks like a 4. That's not true, because in the 3D, so they have a different. So in the 3D in water, it's different than you see it. Okay, not like this. to look at it clearly. So angle is, so the water, this is the water. This is the water we drink every day. We drink millions, billions, and trillions of molecules. We drink all the bent molecule. That's why our throat is bent, right? Okay. Yeah. So realize now water has bent structure. But you cannot see it. You need a very fine electron microscope to see that. It will show nice 3D pictures, how this, we wrote it here repulsive, that you see the repulsive force there, how this energy going back and forth. That's very repulsive. So very nice. You may can see in some Googles, you go look at it sometime. You see that repulsive force that is showing this. But anyway, water has a shape, it is a bent, it has 4 electron groups. It's very hard to realize one thing is, these electron groups here, the lone pair also is electron groups. It is. All the life is about these electrons. These electrons make a bond. These electrons makes our single bond, double bond, triple bond in our body. Sometimes you see, when you take a food items, they say saturated. This is unsaturated. Okay. And then there's a trans bonding. You don't want to eat food with a trans bonding because it is very stable. It's hard to decompose them. Same thing like cholesterol. Okay? There's a balanced groups around it, around the central atom. That's why it's hard to degrade that cholesterol. Saturated fat is the same thing. Okay? If you have a double bond, it's better than having a single bond. It's very hard. Okay? That's the bonding patterns. You go to 14-12 is very interesting. So I encourage you, for those of you who are successful in this course, go take 14-12. You can grab all those relevance to the human beings and you can reflect to you on your diet. When you go buy food, this whale has no trans fat. What did that mean? It's all about bonding in the higher levels. It's very interesting. Okay, so that gives you 5 different shapes. So what is the things you need to learn is, remember these 5 different shapes, 5 different names. Okay, and there's a summary in your book also. Now if I ask you some compound, BeCl2, what kind of shape it has? Find the Lewis. Oh, it looks like a CO2. Okay, then it's a linear. You reference to one of those examples I went through. Makes your life a lot easier. Please do that. It's very easy once you remember this 5. It has 5 different types. Okay, but I have had to give you one more type here. That's not it. That's not the int.